Okay.
Sir, how is everything now? How is your father? Is he better?
Yeah, a little bit. That's okay. Okay. Today, inshallah, we're going to start the new chapter, which is talking about the quantum physics. Or by other mean, modern physics. So the quantum physics is the modern physics. So what is the need for the modern physics? Because some scientists, as Planck, Einstein, and then Hertz, and De Broglie, after 1900, found some observations as the black body radiation observation, the photoelectric emission, and Compton effect. These three observations, the classical physics or the physics before 1900, cannot explain exactly how these three observations happened. So those scientists started to create a new series in order to convince themselves before convince the others why these three observations can happen. So the chapter is talking mainly about the blackbody radiation theory, the photoelectric emission theory, and the Compton effect theory. Do you have a question?
No, sir.
Okay.
Sir, we will explain them, right?
So let's start with the first one, which is
Sir, can you hear me?
before. What is the difference between the
Hello? Hello? Sir, can you hear me? Sir?
and the modern physics?
Sir, can you hear me?
You're talking,
Hello?
Jane?
Sir, can you hear me now?
Yeah,
Yes, sir. Sir, we will explain these theories, right?
yeah. In this chapter, we have to explain all these three observations
Okay.
from the point of view of the modern physics or quantum physics. But
All right.
all the classical physics, they have a very clear description for the matter and the energy. By mean that they classify all the surrounding as matter or particle and energy or wave. And they believe that the matter cannot be a wave or the wave cannot be a matter. So each one has its own properties and they cannot having dual nature. This is the classical physics. So they define the matter or the particle as This matter by mean particle which have a mass, charge, its linear momentum PL is equals to mass times velocity, and it has kinetic energy which equals to half mv squared by mean. Any body has these properties, it means that it's considered as a particle or a matter. So the matter, according to the classical physics, any body which have mass, charge, linear momentum, and kinetic energy equal half mv squared. And he gave us an example for this matter at the electron. So the electron is the smallest building unit for any matter. And he considered the electron as a particle because the electron had the mass, and we know that the mass of electron is 1.9.1 into 10 power negative 31. Its charge is 1.6 into 10 to the power 19. And its mass multiplied by the speed of the electron can give the linear momentum, by mean it can make an collisions. Its kinetic energy equal half mass the electron, the velocity of the electron square. So according to the classical physics, this is the properties of the matter. And for the second classification, which is energy.
Said for the mass of the electron, I mean the charge, is it 1.6 or negative 1.6?
This is the charge. The electron is considered as the negative carrier of the charge because the proton have the same charge, but the proton is the positive carrier. So the electron is only the carrier, but the charge itself is a constant amount in order to make the atom stable. So we have the same amount of charge for proton and for electron, but the electron is considered as the negative carrier of this charge.
So like writing the charge, we don't add the negative sign?
No, we just say negative in order to see that there is a repulsion can happen between two electrons or attraction can happen between electron and proton. But if we are talking about the charge itself, we need the vector or we need the magnitude. We need the magnitude of the charge.
Okay.
And for the energy, or by other mean, a wave, the classical physics say that the wave is considered as a wave because it has some properties, as it can pass through straight line. So it passes through straight line. It can reflect, refract, and it can interfere. And of course, it can diffract. So this is the properties of the energy, or by other mean, a wave. And as an example for this wave, the electromagnetic wave, or the combination between the electric field and magnetic field. So for the classical physics, any particle cannot be a wave, and the wave cannot be a particle because each one has its own properties. So there is no mixing between them. And this is a shortage because of these properties, or because of this point of view for the classical physics, they cannot explain this series.
Said like how?
Because after 1900, some scientists started to examine this nature, by mean examine the properties of the wave and of the matter, and they can claim that the particle has some properties of being wave. So the electron is considered as a particle, but it has some of the wave properties. In some situations, it can act as a wave. And the wave or the energy, according to Einstein, E equal mc squared. So the energy has mass by mean that the energy is considered as a wave, but in some situations it can act as a matter or particle because it has some of the properties. And according to this point of view, they started to put a new end for the classical physics and started to invented some theories or some explanation for the older theories.
Sir, so the particle can form energy, but the energy can be a particle?
Both of them. We will discuss in this chapter the dual nature of both electron and energy or photon. The photon is the smallest building unit of the wave or energy. So we will discuss this. So again, for the classical physics, this is the point of view for both the particle or matter or electron, energy or wave or photon or electromagnetic wave as an example. Each one has its own properties and they cannot mix. The first observation is held by the scientists Planck and Venn, which called Blackbody radiation. First of all, radiation by mean energy, and energy by mean wave, by mean it is a part of electromagnetic wave. And let's remember what is the electromagnetic wave. The electromagnetic wave is a combination between the electric field and magnetic field, which are perpendicular on each other. And they are propagating along the direction of the energy transfer. And the electromagnetic wave consists of a pattern starting from radio wave, micro, infrared, visible light, ultraviolet, and of course X-rays, and finally the gamma radiations. And we said that as we go from up to down, the wavelength decreases, and as we go from up to down, the frequency will increase. So if we said that the frequency or the wavelength changed, it means that the electromagnetic wave type will change because each part of the electromagnetic wave has its own frequency and wavelength range. So Planck started to experiment the different types of radiation which are getting out from different bodies at higher temperatures. And he drew a graph between the temperature in Kelvin and the wavelengths or the intensity of radiation and the wavelengths. And here the wavelengths varies by mean the types of radiation which getting out from the bodies will differ. as we change the frequency or wavelengths, the types of electromagnetic wave will change.
So what is it on the y-axis?
And he found that
Said
for the sun, which has 6,000
So can you hear me? Said
maximum intensity for it
so can you hear me?
at 5,000 angstrom.
So can you hear me? Hello?
And note that the angstrom, of course, we know that it is equal to,
So can you hear me?
yes,
Said what is written on the y-axis?
here, temperature in Kelvin or the intensity of radiation.
Sir, can you explain the graph again? Because I wasn't hearing you.
The graph is between the temperature or the intensity of radiation which is getting out from a different bodies at different temperatures with the wavelengths of the radiation. What I mean, he examined different bodies at higher temperature and he can see what the type of radiation which is getting out. For the first body, which is sun, at 6,000 Kelvin, he found that the maximum radiation for the sun was at 5,000 angstrom. So this is the maximum intensity. And after that, he studied another body as a lamp at 3,000 Kelvin. He found that the maximum intensity is about 10,000 angstrom. And from this graph, you can see that as the temperature decreases, what happens for the wavelengths?
Decreases.
Again, as the temperature decreases, what happened for the wavelengths?
Decreases, sir.
No? The first one at 6,000 Kelvin, 5,000 angstrom, while when the temperature becomes 300 Kelvin, it becomes 10,000 angstrom. So it means that the wavelength increases. So as the temperature of the body decreases, the wavelength range increases.
So can you repeat?
Again, for the first body, it has the maximum intensity or radiation at 5,000 angstrom, while the second one has its maximum radiation at 10,000 angstrom. The first body has a temperature 6,000 Kelvin, while the second one has 300 Kelvin. So for the second body, the temperature decreases, but its wavelength increases. So it means that the relation between the absolute temperature of the body and the wavelength of its radiation is inversely proportional. And this is what Venn states. The scientist Venn states that Venn's law. He said that for a different body, the ratio between their temperature in Kelvin, T1 in Kelvin over T2 in Kelvin, is equal to the wavelength of the second body over the wavelength of the first body. And from this relation, they started to calculate the radiation of the Earth. by knowing the temperature of the Earth's surface, they use this relation and they find that the radiation of the Earth in the gap of wavelengths which exceeds the visible light. And this is the reason why we cannot see the radiation getting out from the Earth, because the radiation which getting out from the Earth was at the range of wavelengths after the visible light, so we cannot see it. So again, according to them, who said that the relation between the absolute temperatures and wavelengths of radiation for different bodies, they can calculate the radiation which is getting out from the Earth. And they found that the radiation was in the range after visible light. So this is the reason we cannot examine this radiation, or we cannot this radiation feel by this radiation, because we cannot see this radiation. So for the first graph, for the Blackbody radiation, Vence noted that as the temperature of the body decreases, the wavelength of radiation getting out from it increases. So there is an inverse relation. And he used this relation to find the radiation which is getting out from the Earth. And he said that the radiation is a range of wavelengths after the visible light, and this is why we cannot see this radiation which is getting out from the Earth. But the problem for Planck was not these informations, but he has here two areas or two regions. We said that as we go from 0 towards the direction of the arrow, the wavelength increases, right?
Yes.
And as a result, the frequency will decrease.
Yeah.
So here we have the highest frequency region, right?
Yes.
And here we have the lowest frequency region.
Mm-hmm.
Planck cannot explain why in the highest frequency region, the intensity of radiation was very small. And in the lowest frequency region, the intensity was very small too. So he searched in the classical physics books about this theory. What is the relation between the intensity of radiation and the frequency? And the result was, in classical physics, they said that as the frequency increases, the radiation will increase. I mean that the relation between the frequency and the intensity of radiation according to the classical physics is directly proportional. Again, the problem in this graph, or the bell-shaped graph of Planck, is at the highest frequency and lowest frequency regions, the intensity of radiation was small. But in the classical physics, they claimed that as the frequency increases, the intensity of radiation increases, and as the frequency decreases, the intensity decreases, by meaning that it is directly proportional. So, in classical physics, again, they claim that as frequency increase, so intensity of radiation will increase too. And Planck said that in the second half of the graph, classical physics is correct. Why? Because here the intensity decreases and the frequency decreases too. But for the first half of the graph, the intensity increases while the frequency decreases. So why this observation happened? Again, Planck said that according to the classical physics, the second half of the graph is correct. Why? Because from the second half, as the intensity of the radiation decreases, the frequency decreases too. So here is correct. While in the first one, the intensity increases, while the frequency decreases. So there is a problem. So the classical physics cannot explain exactly what happened for the blackbody radiation. So Planck started to put his assumptions in order to explain this phenomenon. So the first question is, why the classical physics failed to explain the blackbody radiation? And the answer is because at the regions of high frequency and low frequency, the intensity of radiation was very small, while the classical physics claimed that the relation between the intensity of radiation and the frequency is directly proportional, and this is not correct.
Sir, can you repeat?
Again.
Because I lost connection. Yeah.
Never mind. So the first question is, why the classical physics failed to explain the blackbody radiation theory? Because in the highest frequency region and the lowest frequency region, the intensity of radiation was small, while in the classical physics books, they claimed that the relation between the intensity and the frequency is directly proportional, and this is not correct. So, what are the assumptions for Planck in order to explain this phenomena or this observation? Let's see, but before, there is any question about this part?
Yes, sir.
Yes.
So like if we took the second part of the graph, as we say that the wavelength is inversely proportional to the intensity or the temperature, right?
Yes, the temperature, not the intensity. This graph may be temperature or intensity.
Okay, the temperature. But with the first side, it's directly proportional.
Here?
Yeah.
Why?
Because here the temperature is increasing and the wavelength is increasing too.
For the first one? No, the temperature is constant.
So the graph between wavelength and intensity or temperature?
Intensity at constant temperature. So we need to find the maximum intensity of different bodies at higher temperatures. So the sun has the highest temperature, which is 6,000 Kelvin. So he discussed or explained some bodies at different temperature. By mean, this temperature is kept constant.
Okay, okay. Answer, at the bottom of the left side, there is something like NB, A equal to 10 to the power negative
Yeah.
10. What?
Yeah, the angstrom. The angstrom is equal to 10 to the power negative 10 meter. So when we said that 5,000 angstrom, this is the measuring unit of wavelengths. And this is equal 10 to the power negative 10 of the meter.
Okay, sir.
Jay?
Sir, can you hear me?
I'm losing your sound.
Sir, can you hear me?
Jay?
Sir, can you hear me?
Yeah, now we can hear you.
Yeah, all right.
Any other question?
No.
Okay. So what are the assumptions of Planck in order to explain this observation? So Planck assumption. First of all, Planck defined the first definition of the simplest building unit of the wave, and he called it photon. So the first scientist who put a definition for the photon was Planck. And he said that the photon is a quantum of energy. So again, the first assumption that Planck made, that he put the first definition of the simplest building unit of the wave. And he said that this electromagnetic radiation, or this spectrum of radiation, or this intensity even, is consists of photons. And this photon is a quantum of energy. So he defined the photon as a quantum of energy. Then he claimed that this photon energy is related to its frequency. Why? Because as the energy increases, the intensity increases, so the penetration power will increase by mean the frequency of the wave increases, or by other means. If you give more energy for the body, it will make more vibrations, by mean it will make more frequency. So he said that the energy is related to the frequency, but multiplied by a constant. He called it Planck constant, give his a word or a simple H. So the second assumption that the photon energy is related to the frequency, by mean that if the frequency increases, so the energy of the photon increases, and as the energy decreases, so the frequency decreases. But this energy is not equal to the frequency, it is equal to h times nu, and h is Planck constant. Okay. Then he said that this photon will make an atom which has an excitation. If we have this atom, and this is an energy levels of the atoms, E1, and E3, he said that when the electron jumps between E1 and E3 because of any excitation, then relaxed back again to E1, he lost the amount of energy in the form of photon. So the photon released from the atoms because of the excitation. So the first assumption, and second and third is about the name of photon. He claimed that the simplest unit of building for the wave or energy is called photon. By mean that any radiation consists of a photon, and this photon is a quantum of energy. Its energy equal to h nu, and it released because of the relaxation of electron in an excited atom when it relaxes from higher energy level to lower energy level. I think we said it before, when the energy exerted out or when the electron relaxed, the energy is getting out in the form of electromagnetic wave. Now, Planck said that this electromagnetic wave consists of photons. Okay, so this is the first three assumptions which is talking about the photon. The fourth one, he started to explain what happened in this graph, the bell-shaped graph. As we said, we have a problem. This problem is why in the highest frequency region and lowest frequency region, the intensity is small. And he explained that at high frequency region, the number of photons are very small. Why? Again, he claimed that at the high frequency region, we said that this energy is photons. The number of photons is very, very small. That's why.
Why?
I will give you an example.
Okay.
لو أنا يا جاي for an example معايا 1000 جنيه.
Okay.
وال1000 جنيه دي هفكها ميتينات، يعني ورق من الفئة هم 200 و100 وجنيه. ال1000 جنيه ديت علشان افكها امتينات هيكون عندي كام ورقة من ام 200؟
5.
Jane?
Still, can you hear me?
Yes.
5.
Great. 5.
Yeah.
طب وال100؟
10.
وال1؟
1000.
He said that ال200 دي هي الفريكونسي فاليو. كل ما يكون الفريكونسي كبيرة كل ما العدد بتاعها يكون قليل عشان تديلك نفس الانرجي. طب لو كانت الفريكونسي فاليو قليلة عندي عدد فوتونز كبير جدا، ولكن هل عدد الفوتون الكبير جدا ده زود لي الانرجي؟
No.
يبقى الفكرة كلها ايه؟ in at the region which have the highest frequency, the number of photons were very small, which give a small amount of energy or intensity. While in the lowest regions of frequency, the number of the photons increases, but each photon has a very small value of frequency, so the energy will be very small too. Then كده Planck, according to the photon, he claimed that Y in the highest and lowest and regions of frequency, the intensity of radiation is very small. Because in the highest frequency region, the number of photons is very small, while in the lowest frequency region, the number of photons is very high. But this number of photons will give the same amount of energy, because as the frequency of each photon decreases, it will give you the same energy. We have 5 photons, each one has 200, equals 1,000 photons, each one has a frequency 1. So it is not about the number of photons. It is about both the number of photons and its frequency. So he concludes that the intensity of radiation according to the classical physics is depending on the frequency value, and this is not correct. But according to the photon description, or according to Planck assumptions, he found that the intensity of radiation depend on both the frequency value and the number of photons. And this is why the graph has a pill shape, because the energy at the both sides, highest frequency or lowest frequency, have the same minimum value. Because here high frequency was less amount of photons, but here less frequency was highest amount of photons.
So what about the midpoint of the graph?
Here?
Yes.
Yeah, we have a moderate, but we have a huge amount of photons.
Like the 100 case?
Yeah, because in the next session, we will take something called band theory, and we will find that there is 3 regions at which the electrons can move through: the valence band and the conducting band, and this is our rare. While the forbidden band, or the hugest amount, which has the hugest amount of photons can be released, which is the intermediate band. So we will discuss this later.
Okay.
But for Planck's assumption, he said that the classical physics is wrong. Why? Because it failed to explain why in the highest and lowest frequency region, the intensity of radiation was very small, while according to his assumption, he found that this energy is considered as a photons, and this photons is amount of energy or a quantum of energy which is equivalent to h nu, and h is a Planck constant. And he said that this photon is getting out from the atom in case of excitation only. At the highest amount of photon was found at the region of the little amount of frequency, while the lowest amount of photons can be found in the region at which we have highest frequency value. Any question about this one?
No, sir.
Okay, so this is the first observation. And classical physics was wrong. Modern or quantum physics is correct. The second observation was photoelectric emission. The photoelectric emission observation happened when the scientist Hertz make an experiment. He bring a metal surface, any metal surface, and we know that the metal has free electrons.
Yes.
Which can liberate easily. And he used a different types of radiation. And as we said, a different type of radiation. So we are using different type of electromagnetic wave. So visible, infra, ultra, X-ray, whatever. And by exposing this metal surface to the radiation, he noted that an electric current started to flow, and by connecting this to a sensitive galvano, the pointer deflected as evidence that there is an electric current can pass. And as the electric current can pass, it means that the electrons started to vibrate or move. So Hertz has a question. Why electrons vibrates when a different types of radiation exposed to it? So this is the question. And what is the meaning of the photoelectric emission? The classical physics answered as the photoelectric emission is the libration of electrons from surface of metal when they exposed to electromagnetic radiation. So this is the definition according to the classical physics. So what is the explanation according to the classical physics too? The explanation was in order to liberate electrons, so this liberation of electrons.
Said libration or vibration?
Liberation. Liberation, I mean it ejected. تحرير.
So what did you say?
تحرير.
Okay.
So the liberation of electrons or the ejection of the electrons from the surface of the metal is depending on the intensity of radiation. what the meaning of intensity of radiation? A certain type? No, the amount of radiation. Expose the surface of the metal to a huge amount of radiation. Any type, any type. Any frequency, any frequency. And this libration will not happen instantaneously. It will take a time until the electron started to liberate from the lowest energy level until they reaches to the surface, then they can eject it. So according to the classical physics, they said that the electro or the photoelectric emission is the liberation of electrons from the surface of the metals when they exposed to electromagnetic radiation. And it happened with two conditions. The amount of electrons increases by increasing the intensity of radiation by mean amount, and it increasing by delaying time or giving it more time. By mean that this ejection will not happen instantaneously.
Okay.
But Hertz tried some different ways. By mean, he gives surface and another surface of different materials. So he examined more than one metal and he started to give red radiation to the surface, but no electrons ejected. زود الاماونت اكتر, no ejection. طب نستنى شوية, take time, more time, no. While when he used the violet, immediately at the same time he found that the electrons ejected. ايه ده؟ لأن I get different types of surfaces of metals and exposed it to red color visible light. تطلع red مفيش. اسمع كلام الكلاسيكال, more red برضه مفيش. طب more red with more time, no ejection happened. While لما استخدم الviolet with a little amount, instantly at the same moment the electron ejected from the surface. So he back to the classical and asked, فسروا لي الobservation دي. Why this happened?
So it happened with violet only?
Yes. ليه ده حصل؟ كلاسيكال قالت لا انا ما عنديش اجابه. انا اللي عندي اللي اعرفه ان الفوتو الكتريك emission اللي انا اعرفه happened because of the amount of radiation. كل ما تزود الاماونت of radiation كل ما يطلع الكترونز اكتر, كل ما تديله وقت اكتر يطلع لك الكترونز اكتر. لكن اللي انت قلته ده انا ما اعرفوش. So classical physics failed to explain the second observation, the photoelectric emission. While Einstein started to explain what happened exactly. Einstein said that, so here Einstein Einstein said that in order to liberate electrons from a metal surface, so these electrons needs a certain energy. يعني it will not vibrate كده، لا ده أنا لازم أديها amount of energy معينة. كل surface has its own amount of energy وسماها potential barrier. اللي هو إيه؟ قال لي the potential barrier is the attraction forces between the protons and the electrons. And in order to make the electron liberate, you need to break down this attraction force. And this attraction force need a certain amount of energy. Okay. So how we can give the electrons this amount of energy? And this amount of energy will given to the electron by the photon. Because as Planck claimed, the photon is the amount of energy, because photon energy equal h nu. So if you need a specific amount of energy, you need a specific photon, by mean you need a specific frequency. And as you need a specific frequency, so you need a specific type of radiation. تاني Einstein قال in order to liberate the electrons, so this electron needs amount of energy. This amount of energy differ from one surface to another according to the attraction forces between the electrons and the protons. And in order to break down this attraction force, you have to supply the electron by a specific amount of energy. This amount of energy will be in the aspect of a specific photon. And the photon is equal to h nu. So in order to eject the electron, we need a specific frequency, by mean a specific type of radiation. يعني ايه يا اينشتاين الكلام ده؟ قال لك يعني لو انا عندي سيرفيس محتاج انرجي بتقابل الفريكونسي بتاع الفايلوت، لو انت فضلت تديله ريد عمره ما هيطلع، because هو عايز الفايلوت. يبقى اول حاجه اينشتاين قالها ان خلي بالك الموضوع عامل بالظبط زي انا بحب مثلا السمك، بحب اكل السمك مثلا، فهل اقول لماما اعملي لي اكل كتير، ولا اقول لها اعملي لي اكل من اللي بحبه كتير؟
من اللي بحبه كتير.
جميل. نفس الكلام المحتاج فايلوت، انت عايز كتير هو مش عايز، هو اللي بحبه اللي هو فايلوت، وبعد كده نتكلم بقى كتير قليل مش مشكله. لكن in order to liberate the electron from a surface of a metal, you have to supply the electron by a specific amount of energy which meets a specific type of electromagnetic radiation. يبقى اول حاجه بدا اينشتاين يعدلها. يبقى اول حاجه لا كلاسيكال انت برضو خطا، الموضوع مش محتاج the intensity، لا it depends on the frequency. كل ما الفريكونسي تزيد، كل ما الانرجي تزيد، كل ما انا هبقى مبسوط. تاني حاجه it will not take a time لان الموضوع كله انت محتاج فايلوت، خد فايلوت هات الكترونز. طب محتاج الكترونز كتير، خد فايلوت كتير. يبقى انا معاك الانتنسيتي اوف راديشن تيجي، ولكن بعد ما تديني اللي انا عايزه. يعني اديني الاكل اللي بحبه وبعدين كتير، مش تديني كتير وخلاص. يبقى اينشتاين وضع حد للموضوع يا جماعه ان الفوتوelectric emission it is the liberation of electrons from the surface of metal, but when they are exposed to a specific type of electromagnetic wave meets a specific requirements زي الانرجي اللي هو عايزها. فيها مشكله ديت؟
No sir.
اوكي، تعالي نشرح بقى تاني كده. according to اينشتاين هو عمل ايه بالظبط علشان يديني الفوتو الكتريك emission according to the modern physics او quantum physics.
Okay,
يبقى
but sir, sir, can you hear me?
emission claim that rate the electron it depends on the
Can you hear
intensity
me?
of radiation. Yes.
سر صوتك بيقطع من السماعة.
مش عارف، في مشكلة في السماعة. سمعاني كده؟
هلا
Okay, so the first question is how the classical physics failed to explain the photoelectric emission. So we can say that because it claimed that the libration of electron depending on both intensity of radiation or the amount of radiation exposed to and the time taken in order to eject the electron. While for the modern or quantum physics, it depends on the frequency and it can liberate instantaneously. تعالي.
And the libration is measured by the galvanometer?
No, the libration is the freeing of the electron, and as the electron pass, it creates a current. So it is an evidence that there is an electron passed.
Okay.
Okay. Yeah. Einstein. اينشتاين قال ايه بقى according للكلام ده؟ قال لك والله if we have a metal surface and we exposed it to a certain electromagnetic radiation, so you can notice that the electron started to eject it. And the ejection of electrons will depend on first of all energy of photon, which equals to h nu. So second of all, it depends on the frequency of radiation. And third of all, the intensity. I mean the amount.
Sir, I have a question.
Of course.
Sir, if the energy of the photon and the intensity were dependent on the frequency, then why did we put them in 3 points instead of 1?
هقول لك حالا. So what did the frequency mean and what did the intensity mean? By mean that what happened if we increase the frequency? And what happened if we increase the intensity? Einstein claimed that in order to liberate electron, you have to give the electron a certain amount of energy, which is equivalent to the potential barrier, right?
Yes.
So if we said that the potential barrier of the surface was 5 electron volt as an energy, and I give to the electron 4 electron volt photon. اديته photon عنده frequency بتقابل energy 4 electron volt. The electron will liberate.
No.
Great. اديته كتير من ال 4 electron volt. هل هيحصل liberation؟
No.
Great. طيب اديتك 5 electron volt. ايه اللي هيحصل؟
It will vibrate.
But with zero kinetic energy, because all the energy of the photon will use to overcome the potential barrier. صح؟
Yes.
Great. So the electron will liberate with zero kinetic energy. By mean that the electron has no kinetic energy. طيب أنا اديت له كتير من ال5. What will happen?
The same thing.
But a huge amount of electron will liberate with zero kinetic energy. يعني
Yeah.
لو أنت عايز electrons كتير هدي radiation كتير بس بعد ما تديني certain frequency اللي أنا عايزها أو certain energy اللي أنا عايزها. طب لو أنا عايز بقى أزود kinetic energy of the electron يعني عايز يحصل له liberation ولكن with maximum kinetic energy. أزود مين؟
الانرجي
اللي هي الفريكونسي.
Yes.
قال لي يبقى بص كده ده هنا كله ايه؟ after اهو ده شرط certain frequency هسميها threshold frequency. اسمها ايه؟ threshold frequency او critical frequency. لو انت زودت الفريكونسي عن الثريشولد، ايه هي الثريشولد؟ The frequency which meet the energy needed to overcome the potential barrier. اللي احنا هنا قلنا عليها 5 electron volt. اللي هي هتديني energy 5 electron volt. لو انا increase the frequency than the threshold ايه اللي هيحصل؟ قال لي the kinetic energy of ejected electron هيحصل لها ايه؟
Increase.
يبقى لو انت عايز تزود الكينيتيك انرجي تزود الانتنسيتي ولا تزود الفريكونسي؟
Frequency.
طب لو انا زودت الانتنسيتي بعد الثريشولد so the amount of electrons liberate or ejected هيحصل لها ايه؟
Increase.
يبقى في فرق ما بين الفريكونسي وما بين الانتنسيتي. يبقى لو انا عايز ازود الالكترونز بعد الثريشولد زود لي الانتنسيتي ادي كتير. ولكن لو انت عايز تزود الكينيتيك انرجي اوف ذا الكترون ايجكت زود الفريكونسي. يعني زي ما قلت انا محتاج فايلت بس الفايلت الانرجي بتاعته قد بالظبط البوتنشال بارير. خلاص اديني مثلا الترا فايلت اديني اكس راي. يبقى as you increase the energy by increasing the frequency the kinetic energy of the ejected electrons will increase while as you increase the amount of radiation انت اديتني electromagnetic wave زي الالترا فايلت فطلعت kinetic energy عاليه بدات تديني كتير 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 الترا فايلت يبقى the amount of electrons which ejected out from the surface will increase too.
Okay.
وصل الفرق ما بين الفريكونسي والانتنسيتي؟
Yes.
Okay. So Einstein said that the ejection of electron will depend on the energy of photon which is equal to h nu and the frequency of photon and the intensity of radiation. فالأول يجي مين؟ الانرجي بتاعت الفوتون علشان أقابل البوتنشال بارير. بعد كده أزود الفريكونسي وبعد كده أزود الانتنسيتي. فالترتيب ده هو أفضل ترتيب لللايبريشن أوف إلكترونز، لأني أنا من الأول محتاج أطلع الإلكترون، بعدين أطلعه بكفاءة عالية، بعد كده أفكر أطلع كتير أو أطلع قليل. Then Einstein drew a graph between the kinetic energy and between the frequency. Let's see the graph.
سر الانرجي تبعت الفوتون اللي هي dependent on the frequency كمان صح؟
الانرجي بتاعت الفوتون H نيو.
اوكي.
لسه مع اينشتاين، واللي قال لي ان انا لو رسمت جراف بالمنظر ده ما بين الكينيتيك انرجي وما بين الفريكونسي، فالموضوع هيبقى كالتالي: اني at zero frequency no ejection can happen، صح؟
Yes.
And the ejection of electron will started at a certain frequency called the threshold frequency. صح؟
Yes.
Right. After that, as you increase the frequency, the kinetic energy will increase.
Yeah.
Right. طيب الحبة دول اسمهم ايه؟ يعني for an example لو بقول لك انا عايزك تجيبي لي مثلا الkinetic energy of the electrons، هتقولي لي هو equal ايه؟
في هذا الريجن،
ايه؟
في الريجن قبل ال threshold frequency.
دي ما كانش فيها kinetic energy، يعني انا
اه
عايز الماكسيمم kinetic energy ده اهو.
الماكسيمم.
هيكون بيساوي ايه؟ انرجي الفوتون، لا، انرجي الفوتون ماينس البوتنشال بارير، صح؟ مش انا مثلا اديتك فوتون ب 7 الكترون فولت، هل انت هتاخد ال 7 الكترون فولت كلهم كالكترون وتتحرك بيهم؟ ولا الاول هتقول لي ال 7 الكترون فولت دول انا هشوف البوتنشال بارير محتاج قد ايه، فلو محتاج 4 مثلا يبقى انت هتتحرك بكام؟ 3. يبقى معنى كده the kinetic energy of electron equal to the energy of photon minus the potential barrier. صح كده؟
Yes.
Great. يبقى ال kinetic energy equal to energy الفوتون اللي هي مين؟ H نيو، صح؟ minus ال potential barrier أو بعض الكتب بتسميها work function، عشان لو لقيتي المسمى ده the work function هي نفسها ال potential barrier وبيدوها السيمبل phi. So the work function phi هو نفسه ال potential barrier، واللي هو equal ايه؟ energy برضو، بس H نيو ايه؟ critical أو threshold، مش كده؟ مظبوط؟ جاي؟
Yes, sir.
جاي؟
So can you hear me? Hello. Sir, I can't hear you. Sir, I can't hear you. No, sir, I can't hear you.
سامعاني كده؟
Sir?
saying?
Yes, sir, I can hear you now.
Okay. You have a question here?
No.
Okay. So kinetic energy of electron is equal to h nu, which is the energy of the photon, minus h nu c, which is the work function or the potential barrier of the metal surface. So we can take h as a common factor, and it will be nu minus nu c. So this is the kinetic energy. So we can find the kinetic energy of the ejected electron from this relation. Very important. And of course, Einstein found that for each surface, it has its
Specific potential.
work function. فكل metal عنده work function مختلف according to the material. Only the least work function is for cesium element. And this is why we are using the cesium in plating of
So the cesium is very reactive, right? So can you hear me?
explained again that in order to liberate electrons from
Can you hear me?
you have to expose a certain frequency, which equal to threshold frequency. In order to increase the kinetic energy of the ejected electron, you have to increase the frequency. No.
So what about now? Hello?
And here you very low.
So can you hear me?
Yes, now I can hear you.
Sir, I said that cesium is very active, right?
Yeah, it is from group 1A, the alkali metals. So it is very, very reactive. But it has a property which is that all energy levels are full. So it acts as a screen and block the effect of the nucleus. So it is easy to eject the electron with a little bit amount of any energy.
Okay.
And this is why we are using it for the solar cells, because it has the least work function.
Right.
So even now, we have for Planck T1 over T2 equal what? Lambda 2 over lambda 1. And energy of any photon is equal to h nu. And the kinetic energy equals to h nu minus nu c. And phi, which is the work function, is equal to h nu c. This is the rules for the first and second phenomenon. So the first one was the blackbody radiation, and the second was the photoelectric emission.
Sir, what was phi? Sir? Sir, I can't hear you. Sir, I think you have some problem in the microphone or speakers. I don't know. I can't hear you.
Now you cannot hear me?
Yeah, I can now.
I don't know what's happening. But I'm using this headphones in the session before you.
I don't know.
So maybe I had to change it.
Sir, I can't hear you again. No, sir, I can't.
جاي
سر صوتك بقطع يعني شوي بيجي شوي بيروح.
now, please. Hi. Hi. Jane?
Hello, sir. Hi, sir.
Hear me now?
Yes, I can hear now. Yeah. Sir, can you hear me?
Hi.
Sir, can you hear me?
Hi.
Hello?
It's okay. Hi.
Can you hear me, sir? Sir, can you hear me?
Hi.
Hi.
Jane?
Sir, can you hear me?
I cannot hear you.
Sir, I can hear you, but you can't hear me.
I think the problem is not from mine, because the microphone is working well.
Sir, can you hear me now?
I cannot hear you.
What about now? Yes, sir, I can hear you. Sir, can you hear me now?
Okay. The next phenomena is for the scientist Compton. We called it Compton Effects. So what are the Compton effects? Compton claimed that if we have electrons and then we exposed it to a photon, so he noted that there is a collision happened. How? Because he noted that the electron scattered and the photon too. So when a photon hit an electron, the electron is scattered and the photon. So this is the electron, this is the photon after being collided. But when the photon has energy of h nu, it gives part of its energy to the electron, so the electron energy increases, while the energy of the scattered photon decreases. The momentum of the electron also increases because the momentum is mass times the velocity. And as the energy increases, which equal to half mv squared, so the velocity of the electron increases. While the photon energy decreases because energy is equal to h nu, so energy is equal to h nu. And as the energy decreases, it means that the photon frequency decreases too. While the linear momentum, which equal to mass times velocity, will keep the constant because the speed of the photon is the speed of light, which is 3 into 10 to the power 8. So again, Compton noted that when a photon of energy, h nu, hit an electron, the electron is scattered and its energy and linear momentum increases, while the photon too scattered. By mean, there is a real collision happened. How a collision can be happened between energy and particle. So according to the classical physics, this phenomena is refused because the particle is a particle and the wave is a wave. There is no mixing can happen between them. So the photon cannot collide with the electron. While for the modern physics, they found that this is the evidence that a photon can be acted as a particle. So from this experiment or this effect for Compton, they found that the photon is a wave, but it can act as a particle. So we can say that the photon has dual nature. So we prove the dual nature of the photon from the Compton effect. Why? Because in Compton effect, again, when a photon hit electron, they found that the photon energy frequency decreases while the energy and linear momentum of the electron increases, by mean that there is an elastic collision, because the summation of energy before and after the collision is remaining the same. So there is a real collision happen. And how a collision can be happen between energy and particle. This is a proof that the photon is a particle. By mean, it is a wave having some properties of being particle, or it is a particle which have the properties of being wave. And we call this a dual nature of the photon. So the electron energy is equal half mv squared, because it is half mass. So when the energy increases, the velocity of the electron increases, which increases the linear momentum. While the energy of the photon is equal to h nu. So when the energy decreases, the frequency decreases and the speed will cut constant as it is the speed of light, 3 into 10 to the power 8. فالانرجي لما زادت الفيلوسيتي زادت، وعشان كده المومنتم زاد. ده للالكترون. ولكن للفوتون لما الانرجي قلت الفريكونسي قلت واللينير مومنتم is kept constant، ما اتغيرتش لان السبيد ثابته ما اتغيرتش. طيب احنا استفدنا ايه من كومبتون افكت؟ جاس ساينتست اسمه دي براولي. اوكي، مش احنا قلنا ان الفوتون انرجي it will absorb it by the electron in order to eject؟
Yes.
يعني الالكترون هياخد جزء من الانرجي، صح؟ الجزء ده هيكون to overcome the potential barrier and move by the other part. يعني معنى كده لو انا مديلك 10 الكترون فولت فانت هتاخد 5 الكترون فولت وتتحرك بالباقي. نفس اللي حصل. الالكترون كان عنده انرجي، اخذ some of the energy of the photon absorbed وبدا يحصل له scattering ويتحرك بسرعه عاليه. دي اول حاجه. طيب الانرجي بتاعت الفوتون حصل لها ايه؟ decreases، لان الالكترون خد جزء من الانرجي بتاعته. فلما خد جزء من الانرجي اتحولت مع الالكترون as kinetic energy half mv square، لكن مع الفوتون هي اتش نيو. ففي حالة الإلكترون الفيلوسيتي زادت، لكن في حالة الفوتون الفريكونسي قلت. أوكي. جه ساينتست بقى اسمه دي براولي. وقال لك طيب why not we can find the mass of the photon. مش انت بتقول ان الفوتون has a dual nature by mean it has a wave properties and particle properties، يعني عنده mass. طب ما نيجي نجيب الماس. قال لك مش اينشتاين said that the energy is equal to mc squared. وبلانك قال ان الانرجي equal h نيو. طب ما تيجي نساوي الاثنين ببعض، يبقى mc squared equal h نيو، يبقى الماس equals to h نيو over c squared اللي هي c times c.
قال لك طب ما هو أنا لو خدت frequency over C، مش أنا عندي إن ال V equal lambda into nu، ده من الويف، يبقى nu over C equal to 1 over lambda، صح؟ قال لك يعني أنا لو شلت nu over C ممكن أحط 1 over lambda. قال لك تمام، يبقى ماس الفوتون equal to h over lambda c، وقام مسمي الويف لينس ده دي براولي critical wavelengths. دي براولي critical wavelengths، وسماه the wavelengths at which we can find the mass of the photon. يعني الماس اوف الفوتون يجي عند الويف لينس ده، وانت تقدر تحسبها من خلال ان H equal mc وهي اللينير مومنتم multiplied by الويف لينس لامدا. تاني دي براولي according to كلام كومبتون، وان الفوتون has dual nature by meaning it can act as a wave and particle at the same time، يبقى عنده ماس. فبدأ يفكر، واينشتاين said that the energy is equal to mc squared، وبلانك said that E equal h times nu. So from the first and second equation we can say that mc squared equal h nu، يبقى الماس equal h nu over c squared or c times c. بدأ انه يعمل replacement للفاليو بتاعت النيو over c، قال لك خلاص يبقى نيو over c equal 1 over lambda، يبقى ال m equal h over lambda c. ال m ده هو mass الفوتون، ال h Planck's constant، لامدا هو الكريتيكال او the Pauli critical wavelengths، والسي هي السبيد اوف لايت. يبقى تاني كده according to the classical and modern physics كان في contradictions كتيرة او معارضات كتيرة. For the main three properties او the main three phenomena او three main observations اللي هو كان Blackbody radiation، Photoelectric effect أو Photoelectric emission، وكامبتون إفكت، واللي في النهاية الثلاثة أثبتوا لي إن الكلاسيكال فيزيكس كان عندها شورتج، إن هي ما قدرتش تكسبلين بشكل واضح هم ليه كانوا بيحصلوا، وعشان كده هم بدأوا يغيروا الفكر من خلال الاستعانة بنظريات جديدة قام من خلالها مجموعة من الساينتست أينشتاين، بلانك، هيرتز، فين، كل دول حتى دي براولي استفاد منها، وبدأ إن هو يدوني معنى جديد للدواليتي، إن مش الماتر طول عمره هيفضل ماتر، ولا الويف طول عمره هيفضل ويف، لا the some particles may act as a wave and some waves can act as a particles. فالإلكترون is considered as a particle but it has a dual nature، وده اللي هناخده في الكاثود راي تيوب السيشن الجاية. لكن النهارده قدرنا نثبت ان الفوتون can be acted as a wave but it has some properties of being a matter because it has a mass according to the Pauli، واللي طلع بيساوي h over lambda into c. فيها مشكلة الكلام ده؟ تمام. تعالي كده بسرعة. يبقى احنا لخصنا الموضوع كله في مجموعة من الساينتست، واللي ممكن يجي يسألني ايه الرول بتاع الساينتست دول. فأنا عندي rules of scientists. أول scientist كان عندي كان الساينتست فين، تاني scientist كان ماكس بلانك، تالت scientist كان هيرتز ومعاه أينشتاين، رابع واحد كان كومبتون ومعاه دي براولي. تعال نشوف كده هو كل واحد منهم عمل ايه. اول حاجة then وجد الريليشن ما بين ال radiation intensity أو the wavelength of the radiation intensity and the temperature. وكانت الريليشن T1 over T2 over in Kelvin equal lambda 2 over lambda 1. ده كان ال first scientist. Max Planck هو the first scientist who put a definition for the photon. And he said that the photon energy can equals to h times nu, وعشان كده اتسمى الكونستانت باسمه ماكس بلانك كونستانت. هيرتز واينشتاين هما اللي حطوا لي the main definition of photoelectric emission phenomena. هما الاثنين اللي قدروا ان هما يحطوا لي ده. كومبتون ودي براولي هما اللي اثبتوا الدواليتي of photon وخصوصا دي براولي انه قدر يجيب لي الماس اوف الفوتون in terms of ال wavelengths. فده سؤال ممكن يجي يقول لي what are the rules of the following scientists in quantum physics أو in describing the theories of the modern physics. يبقى دول الفور ساينتست أو مجموعة الساينتست اللي احنا خدناهم النهارده واللي قدروا يثبتوا لي 3 important observations زي ال Blackbody radiation، ال Photoelectric emission، الدواليتي بتاعت الفوتون أو Compton Effect أو تأثير كومبتون بتاع الفوتون. اللي احنا هناخده المرة الجاية، لأن الشابتر ده فيه أكتر من حاجة اتلغت، فاللي اتفضلي في الشابتر ده هو الآتي. حاجة اسمها hydrogen atom analysis، وحاجة اسمها line spectrum، وبعد كده عندي حاجة اسمها band theory، وأخيرا حاجة اسمها X-ray production. لكن الابليكيشنز اللي كانت موجودة سواء على اللاين سبيكترم والباند ثيوري بتاعت السيمي كوندكتورز ديت ما بقتش موجودة، سواء السيمي كوندكتورز أو الجزء بتاع الايميجينج بتاع الاكس راي واللي اتنقل مع الالترا ساوند، الاثنين في الميديكال فيزيكس شابتر. فالجزئين دول بقوا ملغيين من الكوانتم، ما عنديش. انا عندي بس الهيدروجين اتوم اناليسيس مع الكاثود راي تيوب، اللاين سبيكترم والباند ثيوري والاكس راي برودكشن. احنا المره اللي جايه هناخد الهيدروجين اتوم مع الكاثود راي تيوب ونحل على ده، والسيشن الاخيره هناخد فيها مفهوم اللاين سبيكترم والباند ثيري والاكس راي برودكشن، لان الثلاثه ريليتد لبعض شويه. ويبقى فاضل لنا بس النيوكلير اللي هياخد مننا approximately 2 sessions غير الحل، والجزء بتاع الميديكال فيزيكس واللي برضه هياخد approximately 2 sessions، والاسترونومي او الاستروفيزيكس واللي هياخد 3 sessions. في كده حاجه مش مفهومه في اللي احنا قلناه accordingly الكوانتم فيزيكس. right. المره الجايه ان شاء الله هناخد الهيدروجين اتوم اناليسيس مع الكاثود راي علشان يبقى عندنا اكتر من سؤال نقدر نحل عليه. وهبعت لك الجزء بتاع الالكترومagnetic اندكشن، الجزء الاول اللي انت كان في عندك مشكله، وانا ببعته دلوقتي اول ما ينزل على جوجل كلاس روم. هبعت لك اللينك بتاعه واعمل لك بيرميشن، وهبعت لك الكتاب كمان بتاع الريفيجن. المره الجايه ان شاء الله يوم الاثنين الساعه 7 بتوقيت مصر. I sent it to you. I think I sent it to you. Okay. Give me 1 second to see it. Okay. You say that, prove that rho t squared is equal to 3 pi n cube over g, and the first radius is nr, and the second radius is r. Okay. احنا خدنا يا لوجين ان قبل كده ال periodic time t is equal to 2 pi r over v. جت منين الريليشن دي؟ من الفيلوسيتي. الفيلوسيتي inside circle، لو انا عندي circle بالشكل ده فالفيلوسيتي هي السيركمفرنس 2 باي ار اوفر البيريودك تايم، فيبقى كروس مالتيبليكيشن يبقى البيريودك تايم ايكوال 2 باي ار اوفر في. جميل. طيب لو انا عملت سكويرنج للبوث سايدز هيبقى عندي t سكويرد ايكوال 4 باي سكويرد radius سكويرد over v سكويرد. انا هعمل ريبليسمنت دلوقتي للفاليو بتاعت الار اللي هي ان ار، يعني هشيل الار كده اهي وهحط ان ار، فتبقى دي شكلها عامل كده تي سكويرد ايكوال 4 باي سكويرد ان سكويرد ار سكويرد اوفر في سكويرد. طيب وانا عندي ان الفي orbital velocity equals الروت سكوير بتاع جي ام over radius r. دي الاوربيتال فيلوسيتي اللي جت منين؟ اللي جت من السنتربيتال فورس equal to the gravitational force mv squared over r equal gm1 m2 over r squared. كنسلنا ده مع ده بقى لي v orbital equal root square gm over r. هعمل سكويرنج ليها فيبقى ال v squared علشان اعمل ريبليسمنت للفاليو هنا equal gm over r. احط دي يبقى t squared equals 4 باي سكويرد n سكويرد r سكويرد over g m over n r لأن الراديوس ان r. تمام. طيب divided divided اتقلب times فالان ار هتبقى 4 فيبقى الشكل عامل كده d squared equal 4 by squared n cube r cube over gm. لو جيت وعملت both sides multiplied density rho يبقى السايد الأولاني هيبقى rho t squared equal rho 4 by squared n cubic r cubic over gm. مش الرو دي اللي هي mass over volume. يلا هشيل الفاليو دي وهحط mass over volume يبقى m over volume. فادي الماس كانسلد مع الماس. طب والفوليوم؟ مش الفوليوم ده بتاع بلانت يعني سفير يعني 4 over 3 باي r cubic بس الراديوس انهو؟ الار مش الان ار. طب ما اشيل الفوليوم واحط الفاليو دي. يلا يبقى رو t squared equal 1 over 4 over 3 by r cube multiplied by 4 by squared n cube r cube over g. r cube cancelled with r cube الباي cancelled مع السكويرد يتبقى لي من هنا ايه؟ رو t squared equal 1 over 4 over 3 يعني 3 over 4 ال 4 راحت مع ال 4 يتبقى لي من هنا 3 ومن هنا كان باي سكوير راح السكويرد مع الباي يتبقى باي ان كيوب اوفر جي وهو ده اللي هو عايز يثبته. You're welcome. تمام. Any further questions? Okay. Good night. أشوفك على خير إن شاء الله يوم الاثنين.